Hello everyone and welcome back to another episode of Mr. A's Geometry Podcast. Today we're going to talk about midpoint theorem and how we can use it in proofs where we really can't get by without it. Before I do, I just want to remind you, my website, mandrikovic.eboard.com. If you're one of my students, you know it well. If not, if you go there, you can find links to the podcast which will give you access to all the slides that I use here in a PDF and you can download the player. So let's take a look at this midpoint theorem. Midpoint theorem says that if we have a line segment for AB, for example, and you know that M is the midpoint, then there are two conclusions we can make. Now, the definition of midpoint lets us make two conclusions already. Because it's a midpoint, we know that AM is congruent to MB. That's how we define a midpoint. But in class, we've created this theorem that says a midpoint cuts a line in half. And what this allows us to say is that AM is equal to 1/2 of AB. It also allows us to say that MB is equal to 1/2 AB. In other words, that each piece here, the length of AM has to be a half of the whole, and the length of MB has to be a half of the whole. Now this may seem trivial to us as people we look at, and of course that piece is half the whole, but in proof this is required to be shown. And we did show this in class. Go back and take a look at your notes. If not, you can find it in the online notes for my class if you're not in the class. But today we're not going to prove this, we're just going to use this fact in a proof. So this again allows us to just make a statement about the length of the pieces being a half of the whole. So here's the proof that I want to look at with you. And again, you can download this, you can follow along. We have this fairly reasonable looking picture here of a rectangle and a few givens. We're told that B is the midpoint of AC, E is the midpoint of DF, and AC is congruent to DF. Now if we mark the picture up, which we always want to do with a proof, AC congruent to DF, so those are these big pieces. So, if we know big pieces are congruent, this kind of starts to feel like maybe subtraction proof. You're going to see in a minute, though, that it won't be. There's going to be an issue with subtraction here. Before we get to it, let's just keep going with what our givens are. We know that we have midpoints here, so AB is congruent to BC, right? EF is congruent to DE. And they want us to get AB congruent to EF. So what I'm going to do is I'm going to use green to show what it is that we want. So I don't know this, but I'm just going to show in the picture so that you can see what we're talking about. I want to get AB congruent to EF. So again, if you look at this quickly, you've got a large piece congruent to another large piece, right? We know that AB is congruent to, we want to get AB congruent to EF. So we have big pieces, we're going to little pieces, feels like subtraction. Okay. So let me try to convince you that it's not. Let's say we were going to do subtraction. What would we need to take away in order to get BA congruent to EF as we want? Well, we'd have to take away the other pieces, right? We need to take away a CB, and we need to take away a DE. Now, that's perfectly fine, and we can do that. But in geometry proof, if we're going to take something away, well, anytime you're going to take something away, you need to know that what you're taking away from the left is the same as what you're taking away from the right. And we don't know that BC and DE are congruent. It doesn't say that in the givens. Now, it doesn't mean we couldn't show that they are, but here's what I'd like you to notice. Let's say we know already what we have to do to prove that CB is congruent to DE. Let's just say you know the steps, you can do it no problem. Well, whatever steps you have to do to prove CB is congruent to DE would be good enough to prove BA is congruent to EF. And then you'd be done. Right? CB and BA are the same. DE and EF are the same. So if you want to do subtraction, you're first going to have to prove CB and DE and then take it away. But what I'd like you to realize is that whatever you would do to prove CB and DE would be good enough to just prove BA and EF. So that's what we're going to do. We're going to prove BA and EF directly, and to do it we're going to use this midpoint theorem. So let's take a look at the proof. So if we go over here, we have our statements, or our givens rather. B is midpoint of AC, E midpoint of DF, and these large pieces AC and DF. But when you look at these three, something should stand out to you. There's something that needs to be done here that you don't even need to think about. If you've got midpoints, you have to do something with them, right? You can't add or subtract a midpoint. You can't divide with midpoints. You have to do something with that information. So up till now, what we've been doing is saying that segments are congruent, right? Since we have the midpoint, we would say that CB is congruent to BA, or DE is congruent to EF. But now we have this new theorem. Now with the midpoints, we can say if B is the midpoint of AC, then AB is a half of AC. And that's what we're going to do. We're going to go in this new direction and say, since B is the midpoint of AC, it must be true that AB is exactly a half of AC. Right? That's got to be true. AB is a half of AC. And in the same way, since he's the midpoint of DF, EF must be half of DF. So EF is a half of DF. Now what are we going to put for a reason here? Well, we're going to use the theorem that we developed that says a midpoint cuts a line in half. That's how we're going to justify this step in the proof. We're going to refer the reader back to our theorem that says a midpoint cuts segment in half. Okay, well, so why did we do that? Well, look, now we know something about AB and EF. We're trying to prove AB congruent to EF, but we weren't given any statement that involved either one of those two things. So we have to get them in the proof somehow. This is how we do it, by relating them back to those two large pieces. Now, there's a good reason that we want to relate them to the large pieces. What do we know about AC and DF? Aren't they congruent? So if AC and DF are congruent, doesn't that mean AC and DF are equal? Yeah. So that's where we're going to go with this proof now. In step 3, we're going to use this given statement to say that the length of AC has to be equal to the length of DF. That's a simple statement about congruent segments having equal length, right? Congruent segments, equal length. And now hopefully at this point you're seeing something start to fall into place. If AC and DF are the same, right, if they're equal, and a half of AC is equal, if AC and DF are equal, then a half of AC and a half of DF should be equal too, right? And if a half of AC equals a half of DF, then AB and EF should be equal. And those are the two we're after. So how do I say that a half of AC is equal to a half of DF? Well, if I already know that AC equals DF, can't I just come in here in step 4 and say, well, if that's the same as that, then a half of this has to be equal to a half of this. 1 half AC equals 1 half DF. That is surely going to be true. What's my reason? Well, two things. You could say reflexive on 2 and then use division, but we have that shortcut, right? If we're going to do halves, then we can say halves of equal quantities are equal. Halves of equal quantities are equal. And that gives us a half AC equal to a half DF. Now, if I scroll this up a little bit, hopefully you can see that we basically have what we need. If AB is a half of AC, and EF is a half of DF, and a half of AC equals a half of DF, we have a substitution here, right? We can say that it must be true that AB equals EF. AB equals EF. Where am I getting this from? Well, this is a substitution. Which steps are we substituting with? Step 2 and step 4. Let me show you the substitution. You can follow the color. AB is the same as a half of AC, right? These are equal quantities. So all I'm going to do is take this AC, excuse me, I'm going to take this half of AC, and I'm going to replace it with that AB, right? AB is the same as a half of AC, so I take this half AC, replace it with an AB. In the same fashion over here, EF is a half of DF. So I'm going to take this half of DF, and I'm simply going to replace it with an EF. That's where that comes from. So I'm just using these two lines to substitute. Now we have the connection we need. AB is equal to EF. And of course, if AB is equal to EF, then it must be true that the segments are congruent, right? If AB equals EF, then for sure, segment AB is congruent to segment EF. What's my reason? This old chestnut. Congruent segments have equal length. That's just the definition of congruence. And we're done. Put a proof box. That's what we were looking for. Now, just to bring this back full circle to where I started. Remember in the beginning we said this sort of looks like a subtraction problem. We had big pieces. We knew that AC was congruent to DF. And we wanted to get these little guys here. Well, now in the proof, we've shown that indeed AB is congruent to EF, right? This piece is congruent to this piece. We've shown that to be true. But for a moment, just think about the steps that we've done and see if you can convince yourself that those very same steps could have been used to show BC congruent to DE, right? If here, instead of AB equal to a half AC, I had just made it BC equal to a half AC, and DE equal to a half of DF. Then when I do all this substitution down here, I'd have CB and DF congruent. And if you wanted to do that, then you can do your substitution at that point. Partition, substitution, subtraction. But it's not necessary because we've already done enough work to get what we want, namely that AB is congruent to EF, and that's what we were after. So, hopefully that helps. Please download the PDF of this, as I said, from the website. If you have any questions, feel free to come by and see me in my office or email if you're not in my class. Thanks as always for watching. Have a great day.